Today I am going to discuss about the components of a thermal power plant. Now the component, the last class we have discussed about the boiler, superheater, economizer, air preheater and then the condenser. Today we are going to see about the turbine. That is the turbine, the another name is nothing but the prime mover, which converts the steam energy into mechanical energy or the heat energy into mechanical energy. Now the turbines are classified two types. One is for impulse turbine, another one is for the reaction turbine. The impulse turbine means the steam can be ejected completely. That is, the steam is completely expanded in the stationary nozzle and attains a high velocity. But in the reaction turbine, the steam can be expanded partially. That is, in reaction turbine, there is no nozzles are available. The main function of turbine is which converts the any form of energy into mechanical energy. Further, that converted into electrical energy with the help of alternator. But in the thermal power plant, the steam energy or heat energy is converted into mechanical energy. The impulse turbine is nothing but high speed turbine, and the reaction turbine is nothing but the low speed or medium speed turbine. But the maximum in the steam power plant or thermal power plant, they are preferred only for the impulse turbine. This is the schematic diagram of the impulse turbine. Generally, the impulse turbine, the shaft, the position is placed in horizontal shaft. That is, the impulse turbine is nothing but the high speed turbine. The position of the shaft, they are placed in the horizontal. For the reaction turbine, that is the medium as well as for the low speed turbine, the shaft position, it should be either horizontal or vertical. Horizontal or vertical. Now here this diagram is represent for the impulse turbine. The shaft position is nothing but the horizontal. Here the three stages are there. One is for the low pressure turbine, intermediate pressure, another one is for the high pressure. The generated steam in the boiler with high pressure and then temperature that strikes the steam turbine, that is nothing but the low pressure, with the superheater. Directly it strikes the turbine blade. The turbine blades are damaged due to the formation of corrosion. To avoid that one, we are using for superheater. The wastage of the steam in the boiler, the 10% of the steam is wasted. That steam in terms of flue gases that we are using in terms of reheating in the intermediate stage, the reheating in the superheater, economizer and then air preheater. Due to the reheating, we are improve the efficiency 5 to 10%. Generally in the thermal power plant, the efficiency we are getting only 29%, the 71% in terms of losses, 71% in terms of losses. By using these, the flue gases we are reheating in the intermediate stages, we are improving the efficiency, that is 5 to 10%. We are improving the efficiency, that is we are getting 30 to 35%, 30 to 35%. That is in low pressure turbine. Suppose for example, we can take in the low pressure, the turbine is rotating either 1180 rpm or 1200 or 1220 rpm. In the intermediate pressure type, it should be comes from either 1320 or 1380 rpm. In the high pressure turbine is rotating for 1500 rpm. Now, the function of the turbine or prime mover, which converts the steam energy into mechanical energy. Further, this mechanical energy converted into electrical energy with the help of alternator. Another name of alternator is nothing but the AC generator. Is attached on the same shaft of the turbine. Attached on same shaft of the turbine. The next the component is water treatment chamber. In steam power plant, the maximum amount of the steam is wasted in the turbine. That is, the 54% of the steam is wasted in the turbine, that is ejected in the turbine, that collected in the condenser, that and this condensate fed back as hot heater from the fed heater to the boiler. That is, in the water treatment chamber, the wastage steam, that is the 54% of steam wasted in the turbine. Now here we are using is nothing but the impulse turbine. This is nothing but the turbine blades. We are injected the steam with the help of nozzle. We are injected the steam with the help of nozzle. From one blade to another blade, the gap is there. In this gap, the steam is wasted. In the gap, the steam is injected. That is the 54% of the losses in the thermal power plant due to the turbine. That steam collected in the condenser again that utilized as a fed water. And the water we have taken is nothing but from the river or lake or canal, and dissolved impurities or dissolved gases. Dissolved gases. Generally, here in the thermal power plant, we need to supply the water is nothing but the DM water. That is nothing but the demineralized water, or it is represent for the RO water, or is nothing but the RO water. Generally, the available the water is nothing but the raw water. Directly, we can send it to the boiler with the help of the fed water. The boiler, the lifetime is minimized, and the efficiency is also reduced, and the both the output efficiency as well as for the boiler efficiency due to the formation of the corrosion in the salt particle in the water. To avoid that one, we are using the water for boiler is demineralized water or RO water, or simply it is represent for the soft water to improve the lifetime of the boiler as well as the maintain the efficiency is constant. To maintain the efficiency is constant throughout the period. Generally, the boiler the lifetime is 30 to 50 years. The boiler the lifetime is 30 to 50 years. To maintain the efficiency from during the whole period, that is from starting the power plant up to the lifetime of the power plant, we can maintain the boiler efficiency as well as the output efficiency is maintained constantly. That is the efficiency we are getting is nothing but in that the boiler 85 to 90%. Again, here we are using two types of boiler. One is nothing but the water tube boiler, another one is for the fire tube boiler. We are using only the water tube boiler. Water tube boiler means water is flowing inside the tubes surrounded by the temperature, that is surrounded by the fire. Here in the water tube boiler, the efficiency is 85 to 90%. The 10% is losses in terms of flue gases. These flue gases we are reheating in the intermediate stages, utilized for the superheater, economizer, and the air preheater. And the next one is electrical equipment. Once we have generated the power, immediately we need to send to the consumer via transmission and the distribution line. Via transmission and the distribution. In the turbine, that is the impulse turbine, or simply it is represent for the steam turbine, which converts the steam energy into mechanical energy. Further, that mechanical energy converted with the help of alternator. The alternator, the another name is nothing but AC generator. Is coupled on the same shaft of the turbine. Coupled on same shaft of the turbine. Based upon the power generation, n number of alternators are connected in series. That is 2 number of unit, 3 number of unit, like that it should be classified. That is 2 number of unit means 2 set of alternators are connected in the power plant. That is the alternator, the function is nothing but the mechanical energy converted into electrical energy, and the alternator is attached on same shaft of the turbine. The next one, the transformer. Generally in the power plant, there are 3 types of transformers are using. One is nothing but the step up transformer. One is nothing but the step up transformer. Generally in the any power plant, that is either hydro power plant or thermal power plant, nuclear power plant, gas or diesel power plant. The power plant they are using 3 transformers. One is nothing but the step up transformer. Another one is for the station transformer, and the next one is auxiliary transformer. The step up transformer is nothing but the step up the generated voltage for transmission of power. Actually, in the generating station, they are generated power in terms of the operating voltage, that is 3.3 kV, 6.6 kV, and then the 11 kV. In the generating station, they are generated the voltage in terms of 3.3 kV, 6.6, and then 11 kV. They are generated 3.3 kV, 6.6 kV, and 11 kV. They are step up the voltage. They are boost up the voltage into based upon the line length or based upon the distance. 66 kV, 132, 220, 400, and then 765 kV. In India, The maximum, the AC, the transmission line is the 765 kV. The operating voltage in the AC transmission line, the maximum of the operating voltage is 765 kV. This is nothing but the AC transmission line. Based upon the distance or based upon the line length, they are boost up the voltage into 33 kV, sorry, 66 kV, 132, 220, 400 or 765 kV. This is the function of the step-up transformer. The step-up transformer, they are used only in the generating station. Remaining all the places they are used is nothing but the step-down transformer. Only the step-up transformer, they are another name of step-up transformer is nothing but the power transformer. They are used only in the generating station. Remaining all the places they are used for step-down transformer. The next one is nothing but the station transformer. The function of the station transformer used for general service, that is nothing but the lighting purpose in the power plant itself. In the power plant, actually, in the power plant, the lighting is required in the panel board, in the generating station, from all the places. That is the coal handling plant, coal storage plant. Inside the power plant, the lighting is required. For that purpose, they are used for station transformer. Station transformer is nothing but the step down transformer. The capacity is nothing but the 11 kV. The capacity is nothing but the 11 kV. That the 3.3 kV or 6.6 kV, they are converted into the, with the help of the step-up transformer, they boost the voltage. Separately, they are kept for the station transformer. They will be bring, that is nothing but the 440 volt three-phase supply. The 440 volt three-phase supply. Actually, the station transformer, the capacity is nothing but the 11 kV. These 3.3 kV or 6.6 kV or 11 kV, they are stepped down into 440 volt. That is three-phase, three-wire system or three-phase, four-wire system. And in that the particular power plant, they are using for the lighting purpose the supply, lighting purpose supply, and the small remaining for motor, for drinking purpose water, and so many the purpose charging the batteries, for charging the mobile fan, using for office the AC, refrigerator, the so on etc. For supply in that the power plant they are using for the station transformer. And the next one is nothing but the auxiliary transformer, which supplies to individual unit accessories. Individual unit accessories. Suppose if the panel board is available, to operate that panel board, they are given for the separate supply. That is, they are with the supply they are given with the help of the auxiliary transformers. The transformer, the main function is nothing but the step up or step down the voltage. It transfers the electric energy from one circuit to another circuit or one place to another place without changeover of frequency. Here we can increase or decrease the voltage. Another one, we can transfer the electric energy from one circuit to another circuit or one place to another place. We are changing the frequency and we are changing the power factor. The next one is nothing but the exciter. The another name of exciter is nothing but the DC generator. Why they are used in the power plant means the exciter is used all the power plant, thermal power plant, hydro power plant, nuclear power plant. The main function of the exciter, in order to start an alternator, field requires magnetism. That is, the size of the alternator size is big. The permanent magnet does not serve this purpose since direct current is fed into the poles of the alternator. That is, we can supply the DC supply to the field system or rotor to start the initial stage. For that purpose, we are using for the exciter. The exciter is attached to the same shaft of the turbine. This exciter is attached to the same shaft of the alternator. That is, the turbine, the outlet is connected to the alternator. The alternator outlet is connected to the exciter. It is attached on the same shaft. Here, and one more thing, the exciter, the capacity, that is the exciter, the capacity is 0.5 to 3% of the alternator capacity. Suppose in alternator we are generating for 100 megawatt. In alternator we are generating for 100 megawatt. In that the 3%, that is AC power generation. Alternator, the another name is nothing but the AC generator. With the help of the alternator we are generated 100 megawatt, that is the AC supply. Here we can generate the 3 megawatt of the DC power with the help of exciter. That is, the exciter, the capacity is nothing but 0.5 to 3% capacity of the alternator. Here in the power plant itself, we can generate the DC supply also with the help of exciter. With the help of exciter. And the next one is nothing but the switchgear equipment or switchgear instrument. This equipment which locates the fault on the system. We can identify the fault on the system and isolate faulty part from the healthy section. Suppose if any of the conductor is failure in the particular area, with the help of the switchgear and then isolated switcher, we can disconnect in the faulty section. The remaining healthy section we can give the supply. That is, the switchgear means the consists of circuit breakers, relays, switches, and other control devices. This all comes under for the electrical equipment. And the next one is nothing but the chimney. Here, the function of the chimney is to emit the exhaust gas sufficiently high to avoid the trouble to the surrounding people. Actually, in that the thermal power plant, it polluted to the environment, that is, it releases due to the fumes, sulfuric oxide and then nitrous oxide. Due to the sulfuric oxide, all the living organism is affected, that is leaves, grass and the vegetables. Due to the nitrous oxide, the human being is affected due to the inspiration or respiration problem, due to the breathing problem. To avoid that one, the thermal power plant is constructed away from the populated area, that is 15 to 20 kilometer or 30 to 50 kilometer away from the populated area. The chimney, the height is 90 to 150 meter, that is ground level to the top level, or else the simply it is represent for 2.5 to 3 times height of the power plant. 2.5 to 3 times height of the power plants. That is, the chimney is a vertical tubular structure. They are constructed by using steel chimney or else the cement concrete chimney. The maximum all the power plant they are preferred for the cement bricks chimney, because the lifetime of the cement brick chimney is 50 years and the maintenance is also very less. If you go for the steel chimney, the lifetime is only 15 years. In the steel chimney, the lifetime is only 15 years. And the maintenance is required. We want to apply the regular painting. Here, the main drawback is the power plant is operating in a day 24 hours, in a month 30 days, in a year 365 days. The power plant is operated continuously, but the maintenance is very difficult, and the regular painting apply is also very difficult. This is nothing but the chimney. And maximum they will be preferred for the brick and then concrete chimney. And in this diagram, you can observe here the left side, this is nothing but the cooling tower. This is nothing but the cooling tower, and these two is represent for the chimney. These two is represent for the chimney. And one more the small thing, the water treatment chamber in the thermal power plant, the two parameters is required. One is for the water, another one is nothing but the fuel. The water is used for the boiler purpose. To convert the water into the steam. That steam drives the steam turbine. Actually, here the water, if it should be plant is constructed neither to the seashore or lake, water we are carried. Otherwise, in the power plant itself, we are constructed for the water treatment chamber. From this, the water we can take from the open well or borewell. And the next component is the cooling tower. Actually, at present, the demand is increased heavily. To justify the particular power plant, that is, in the thermal power plant, the temperature is maintained from 250 degrees centigrade to 500 degrees centigrade. 250 degrees centigrade to 500 degrees centigrade. And one more thing, in the thermal power plant, the minimum time to generate the power it takes 6 to 8 hours. That is, the room temperature is 27 degrees centigrade. It should be bring the 220 degrees centigrade. The thermal power plant, the power generation started in terms of megawatt. The minimum temperature is required for 220 degrees centigrade, but the power plant, the temperature is maintained from 250 to 500 degrees centigrade. And initially, the time required to generate the power, the initial time period is 6 to 8 hours, or minimum 12 hours is required. To maintain this temperature. And throughout the period, the temperature is maintained for the constant. And in the conventional power plant, the main advantage is nothing but we can generate the bulk amount of power at a time, and we can maintain the constant power generation. and we can maintain the constant power generation. Now, the cooling tower is a semi-enclosed device. The cooling tower is a semi-enclosed device for evaporation, the cooling of the water by controlling with air. That is, the hot water is coming from the condenser. That is, the steam ejected in the turbine, the 54% that is collected in the condenser, that the vapor is converted into the water that circulated to the cooling tower. Again, that send it to the boiler, send it to the boiler to maintain the same temperature. Due to this, the cooling tower, due to the fed water, we can maintain the boiler efficiency is 10 to 15%. We can improve the boiler efficiency 10 to 15%, as well as we are saving the fuel is 5 to 15% of the fuel. We can saving the fuel is 5 to 15%. Here, the cooling towers are classified for three types. One is for atmospheric cooling tower, natural draft cooling tower. Another one is for the forced draft cooling tower. Based upon the cooling tower, the arrangement, it is classified for three types. One is for atmospheric cooling tower, natural draft cooling tower. Another one is for the forced draft cooling tower. Now you can observe in this, the diagram is the atmospheric cooling tower. Atmospheric cooling tower. Now, in this atmospheric cooling tower, the water is carried from the top level, that is the hot water. This is the condenser. Here the turbine is there, the steam turbine. Here the 54% of the steam is ejected, that collected in the condenser. Here the water is carried from the canal or well or lake, otherwise the storage water tank with the help of the pump. The water is flowing, that water is sent it to the hot water. Now, the top of the falling in that the cooling tower, that is the hot water is allowed to fall over the layers, that is the water is spreading the slowly. The bottom of the particle, that is atmospheric air, is entering. In this, due to that, the flow of air, the water particle, the some amount of the temperature is minimized, and the outlet in the cooling tower, the hot air is coming. The hot air is coming. Again, this water is fed to the fed water pump and circulated to the boiler through economizer. And this is nothing but the atmospheric cooling tower. And this atmospheric cooling tower we are using only for the small power plant. It is not applicable for the large power plant. It's applicable only small power plant, that is nothing but the diesel power plant. Diesel power plant. The next one is nothing but the natural draft cooling tower. Natural draft cooling tower. Here, this natural draft cooling tower is a closely built structure. Now you can observe the right hand side. This is nothing but the natural draft cooling tower. This is nothing but another name of natural draft cooling tower is induced draft cooling tower. Another name of natural draft cooling tower is induced draft cooling tower. Here, this is the construction is closely built structure. The height is somewhat quite tall, and the top portion working as a stack operation. The top portion working as a stack operation. Now, here the ground particle, the air it will be entering from both sides. The ground particle, the air it will be entering. In the top portion, that is the hot water is coming through the nozzle. The water is spreaded from top portion to the bottom portion. Now the atmospheric air is entering from ground particle to the downwards to the upwards. Due to that, the water is the flowing top to the bottom, and the moment of the temperature is minimized. Actually, here in that the hot water, the temperature is either 120 or 130 degrees centigrade. Direct, we can send it to the boiler through economizer means. Again, suddenly the efficiency is increased. Actually, here the maximum the temperature we stand in the thermal power plant is 500 degrees centigrade, but maximum up to 560 or 570. Suppose if beyond it crosses, again the problem is arises. Again, that much of the steam is drives the steam turbine. Turbine blades are damaged. To avoid that one, we are using this method. Now here the water is carried from the river or lake or storage water tank. Now again this water is fallen into the ground. The water is collected in the cold water basin. This again the pump into the fed water pump, send it to the boiler through economizer. This is nothing but the water is inlet. The water is spread into the through nozzle, and the water is going into the through lower gloves, and the air it will be sucked into the bottom. It will be go to the upward. The water is somewhat, the temperature is minimized. That the cold water is collected in the bottom basin. Now the hot air is coming out to the outlet of the cooling tower. The outlet of the cooling tower. And the next one is nothing but the forced draft cooling tower. In the name itself available, there is nothing but the forced draft cooling tower. We are given for the additional force. We are given for the additional the supply, that is we are for cooling purpose. We are given for the additional system we are using. We are using for additional the forced draft fan. The bottom of the cooling tower we are placed for the forced draft fan, that it will be applied for the given the some amount of the supply for rotating of the fan. Due to that, the cooling is taken place. Here also the same thing. The top portion the hot water is carrying. Now you can see here, this is nothing but the hot water is inlet. The hot water is inlet. The water is fallen into the ground side. Here we are given, this is nothing but the atmospheric air. We are taken from the forced draft fan. Forced draft fan. Forced draft fan. Due to the forced draft fan, the air it will be going to the upwards. That is the water, it will be the temperature is minimized. That water is collected in the cold water. And cold water means here not for the actual temperature. Here the temperature it should be maintained from minimum, that is either 60 degree or 70 degree up to the 120 degree the temperature is maintaining. And the water it will be eliminated, and the hot air it will be go to the outwards. Hot air it will be go to the outwards. This is nothing but the cooling tower. There are three types of cooling tower. One is nothing but the atmospheric cooling tower, natural draft cooling tower. Another one is for the forced draft cooling tower. And the maintenance of the next topic is the maintenance of the thermal power plants. The maintenance of the thermal power plants. Generally, in the maintenance of the thermal power plant means we will go for daily maintenance, monthly maintenance, quarterly, half yearly, as well as annual maintenance. Actually, the thermal power plant is operating throughout the period. In a year, 365 days. In a year, 365 days, the thermal power plant is operating. Here, the daily maintenance is required. Daily maintenance means we can visit the entire part of the power plant. That is, we can check for the leakages. Any leakages is available. That is, once the steam is generated in the boiler, once the steam is generated in the boiler, the steam we can take from the turbine through the pipeline. Here in this the pipeline, the top they are applied for the gunny bag with lime. They are applied for the gunny bag with lime without leakage of the steam, because in the thermal power plant the efficiency we are getting for the 29%. We are reheating in the intermediate stages. We are improving the efficiency only for 5 to 10%. 5 to 10%. That is the overall the output we are getting, the overall efficiency we are getting only for 30 to 35%. The overall the efficiency we are getting only for 30 to 35%. 30 to 35%. To improve the efficiency, we can take without leakage of the temperature. Without leakage of the temperature. That is, we are carried from boiler to the turbine in the pipeline. The pipeline, the some amount of the steam is leakage. Due to that, again the efficiency is reduced. Again the efficiency is reduced. The efficiency is fallen into either 24% or 25%. To avoid that one, they are applying the gunny bag with lime to avoid the leakage. That is the daily maintenance we can visit for the entire power plant. Any leakages is available. And the monthly maintenance means we can observe the rotating part. That is the pulverizing mill, either ball mill or bowl mill, ball and hammer mill, and then grace mill. And the coal feeder. That is the coal can be carried from the coal handling plant to the boiler furnace with the help of the belt conveyor. You can observe that is working for properly or not. And the coupling bolt of the primary air fans. That is nothing but the forced draft fan. They are used for air preheater, collected the atmospheric air, and the bolt nut is there, and auxiliary component of the boiler, turbine, as well as for the generator. This we can observe for the monthly maintenance. And the quarterly maintenance means that is 3-month maintenance. That is foundation of the all the mission. That is the foundation of the bed. That is the rotating part, the turbine or alternator. the vibration is there. Due to that, the vibration, some of the times, the missions is damaged. The missions are damaged. The bolt head is loose. To check for the every 3 month once, every 3 month once, and discharge depth of the induced draft fan. Induced draft fan, that is the completely the properly it is operating. All the air it will be go to the chimney. There we are placed for the induced draft fan. The collected the duct particle or not. We can observe this thing in the every 3 month once. And half yearly maintenance, that is nothing but the 6 month maintenance. We can visit for the bearing part of the pulverizing mill, the bearing part of the pulverizing mill, and rotating part of the machinery. Rotating means both turbine as well as for the alternator and then exciter. Every 6 months the maintenance is required. And the yearly maintenance is comes for the two parameter. One is nothing but the boiler, another one is nothing but the turbine. The boiler we are inspected once or twice in a year. Again, the separate the inspection is there. The visiting of the boiler committee, they will be inspected and given for the report. Now the boiler condition it should be either good or average or bad. Based upon the thing, again there the maintenance is required, or else we can replace for the complete the boiler, the system. And the turbine as well as for the alternator, they inspected every yearly once. The once in a year, they need to inspect for the turbine as well as for the alternator, that is yearly once. These are the maintenance of the thermal power plants. And the next one, the main control in the thermal power plant. In the thermal power plant, the main control is nothing but the three parameter. One is nothing but the automatic control of boiler, control of turbine, another one is nothing but the control of alternator. These are the major the component, the control of the thermal power plant. In automatic control of boiler means, in the boiler, the temperature is maintained from 250 degrees centigrade to 500 degrees centigrade. If you go for in modern thermal power plant, it is available the automatic control of the boiler. In automatic control means whenever the temperature is fallen to either as per the load, as per the considered load, whenever the temperature is fallen, automatically the fuel, the feeding, it should be started, the automatic operation. For example, the load is for two types. One is nothing but the base load, another one is nothing but the peak load. There are two types of load. One is nothing but the base load, another one is for the peak load. In base load, in a day complete 24 hours, in a year 365 days, the load is maintained for constant. In the peak load, within short interval of time, the load is increasing. Again, it is coming from the actual position. Based upon the load, the automatic operation of the boiler. If the load is increased, again the boiler, the temperature should be increased automatically. Once the temperature is increased, means the fuel utilization is also more and the water utilization is also more. It should be operated for the automatic. At that time, the output it should be maintained for the constant and we can improve the efficiency. Next one, control of the turbine. Control of the turbine. Based upon the demand, automatic the turbine control is there. Here the main thing is nothing but, suppose the demand is 80 megawatt. Now in the particular power plant, they are generated for the 100 megawatt power. They are generated for the 100 megawatt. Remaining 20 megawatt in terms of losses. The 20 megawatt the power is losses. At the same time, the fuel utilization is also we are not saving. Actually, the fossil fuels are depleted day to day, and available fossil fuels we can utilize only for short interval of time. That is, we can use only for 3 to 4 years. 3 to 4 years. That's why we need to save for the fuel with the help of the automatic control of the turbine. And the same, once the turbine is controlled automatically, means the alternator is also controlled. And these three, it should be go for the control of the system. One is for the boiler, turbine, alternator. We can maintain the efficiency is the constant, as well as the power generation is maintained for the constant. Power generation is maintained for the